In question 1, we are asked to find the mean and variance of this data given. So let's start with mean. Let's call it mu, which is sigma x over n. That means we have to add all of them and divide by how many they are. So 5 So 5 plus minus 2 is 3, plus 12 is 15, plus 7 is 22, minus 3 is 19, plus 2 is 21, minus 6 15, plus 4 90, plus 8 27. Over 10, that makes average mean equal to 2.7. Now variance. The formula for variance is sigma x square over n minus mean square. Or this you can write as sigma x over n, which was earlier found here, square. But since we know the mean, so I will use the mean straight away. So here we'll again add the squares of all the data. Minus 2.7 square. That's the mean square. Which, if I use my calculator to do this, we get 27.8. Let's move on to question 2. The number of phone calls X received per day by Sarah has the following probability distribution. Okay, this is the probability distribution table. Find the value of K. So we know that the sum of all the probabilities of any distribution is equal to 1. So this is what we'll do now. We'll write 0.24, which is this one, first one, and so on. We'll keep on adding all of them and we'll find the value of K. Sorry. Okay, so now 2k plus k is 3k, and let's add these two. 0.24 plus 0.35 will be 0.59, 0.64. 1 minus 0.64 when they come to the right side. So 3k equal to 0.36, and that will give us k equal to 0.36 divided by 3, which is 0.12. Find the mode of x. So the mode of x will be the one which will have the highest probability. So let's interpret these two into probability. So this will be 0.24. This will be 0.12 because that's the value of k, 0.12, yeah. So out of these all, this has the highest probability, 0.35. That means the mode of x is 1. Next, find the probability that the number of phone calls received by Sarah on any particular day is more than the mean of the phone call received per day. So let's see how many average number of calls they received. So mean is same as expected value, and expected value is 0 times 0.24. So we multiply x with its probability, and basically it is sigma x ex. Okay, so we will add 1 multiplied by 0.35 plus 2 multiplied by 0.24 plus 3 multiplied by 0.12 plus 4 multiplied by 0.05, and greater than 5 they're saying it's 0, so it will be 0 total, so no need to write anything after this. So this is 0, so we will not count this. 0.35 times 1 is 0.35, 0.2 times 0.24, 0.48, and 3 times 0.12 is 0.36, and this 4 times 0.05 will be 0.2. Okay, so let's see how many it gives us. So this will be A3, 1.29, 1.39. 1.39 calls per day. That's the mean, and now we will see which is more than 1.39. So 1.39, more than 1.39 will be 2, 3, 4, and more than 5. These are the ones, right? So now we'll just add their probabilities. So probability that x is greater than 1.39 will be the probability of 2, which is 0.24, plus 0.12 plus 0.05. Which will be 0.36 plus 1, 0.41 is the probability that it will be more than the mean number of calls. Okay, let's move on to the next question, which is this. Judy tosses a biased coin and throws two fair tetrahedral dice. Okay, biased coin. Okay, a biased coin and two dice. The probability that the coin throws the head is 1 over 3. So probability of head is 1 over 3. That means the probability of tail will be 1 minus 1 over 3, which is 2 over 3. Each of the dice has 4 faces, number 1, 2, 3, 4. Since it is a fair die, each one is a fair die, that means the probability of 1, 2, 3, 4 each is 1/4, 1 out of 4. Jody's score is calculated from the numbers on the faces of the dice lands on as follows. If the coin shows a head, the two numbers from the dice are added. Okay. If the coin shows a tail, the two numbers from the dice are multiplied. Okay. So that means we will have to make two tables. 1, 2, 3, 4. First die. 1, 2, 3, 4. Second dice. And let's do if the coin is a head. So this is the table for head. So if the coin is head, the two numbers from the dice are added. So 1 plus 1 will be 2. Let me do it with something else. Okay. 2 and 3, 4 and 5. And similarly 3, 4, 5, 6. 4, 5, 6, 7. 5, 6, 7, 8. And now we'll make a table for tail. So 1, 2, 3, 4. First dice, second, 2, 3, 4, second die. Alright, so now we need to find the score if it was tail. And if it was tail, dice are multiplied. So 1 times 1 will be 1, 1 times 2, 1 times 3, 1 times 4. 2 times 1, 2 times 2, 2 times 3, 2 times 4. 3 times 1, 3 times 2, 9, 12. 4 times 1, 8, 12 and 16. Alright, now find the probability that the coin shows a head given that the Judy score is 8. So we want to find the probability of head given that Judy's score is 8. So it will be probability of H intersection 8 divided by probability that Judy gets 8. So let's focus on Judy gets 8 first. So it is 8 here, nowhere else. 8 is here and 8 is here. So the probability of getting this 8 will be first, the Judy should get a head. And the probability of head is 1/3. So probability of 8 in all. Well, first she should get a head, which is 1/3. And then there are 16 possibilities, but one of them is 8 only. So that's how this probability comes about. Or she gets a tail, which is 2/3, and she gets this 8. What is the probability of this 8 and this 8? Total 2 out of 16, right? I hope there is no other 8. Yeah. And now we'll just add these two. So 1 over 48 plus 4 over 48, that makes it 5 out of 48. That is the answer for getting an 8. Now, in those cases, all the cases, how many times do we have a probability of a head and 8? So head and 8 is this case, isn't it? So probability of head and 8. Okay, the intersection of the two will be 1 out of 48. So finally our answer will be 1 out of 48 divided by 5 out of 48. 48 cancel. Answer will be 1/5. This is your final answer. Okay, you can write this whole thing here because in middle you should not let your answer to be in the middle. For the sake of explaining, I have done it this way. Let's go to the next question, which is stem and leaf diagram here, back to back. Okay, they are talking about the time to load an application on 61 smartphones. So type A and type B. 61 here, 43 there. Okay, find the median and quartiles of smartphones of type A. So we have to focus on type A only. So median, total they are how many? 61. So the position for the median will be 61 plus 1 divided by 2, which is 62 divided by 1 to 31. The 31st data will be the median from any corners. Let me start from the smaller one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 3, 4, 5, 6, 7, 28, 29, 30, 31. This is the 31st data, and it is, what is the key here? If it is 5 and 2, which is equal to 0.52. So the median, let me write here, median of type A is 0.52. Now we have to find the quartiles. So first I will write a lower quartile, that is Q1, lower quartile. Okay, so if there are 31st is the median, that means there are 30 before this, which will be your median of those 30 will be your Q1. 31st will not be included. That means 2 will not be included anymore. The lower 30 will find the median of them. And since they are even numbers, so we will add, we'll first half it, which is 15th. So 15th plus 16th number, whatever they are, we'll divide them by 2, and that is the median of the lower half of the data except for median, and that will give us Q1, lower quartile. So 15th and 16th. So we have to find 15th first. 1, 2, 3, 4, 5, 6, 7. Please be very careful, never count from this side because we have to start from small. Okay, 8, 9, 10, 11, 12, 13, 14, 15 and 16. These are the two. So 0.42 is 15th, 0.40 is 16th, and divided by 2. Their average will be 0.41. This is Q1. Similarly, we'll find the median of the upper half except 31st, which is the median, and that will become the upper quartile, which is quartile 3, upper quartile. Okay, so we'll start from this one, which is here. So 15th and 16th again, because they are also 30. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is 15. So 0.78. That is the 15th. And 16th is 0.80. And their average will be 0.79. This is the upper quartile. Okay, done that. You're given that the median of low quartile, upper quartile, median are blah blah blah. Okay, represent the data by drawing a pair of box and whisker plot in a single diagram of the graph paper. Okay, let me add grids to this and I'll be ready with the graph when I'm drawing. Done that, and let's see what do we need. This is the scale I have drawn. and I started with 0. There is no negative number there, and 0.25, 0.225, so it will be somewhere in between. So let me write here. This is 0.23. Okay. Next, 0.41 is the Q1. So 0.4 and 41 will be little more than 0.4. Okay. Then we have 0.52 as median. 0.5 and 0.52 here. Then we have Q3, which is 0.79, close to 0.8. Yeah. And the highest one was 0.98, very close to 1. Yeah. Okay. So now we will draw vertical lines and horizontal lines for Q1 first, which is 3 above this line and 3 below. Okay. Same for median. Okay. And they don't look parallel. Okay. Better. Then for Q3. All right. Then horizontal lines, connect them. And we draw with the minimum, we connect it with the minimum, and we connect it with the maximum as well. This is the box and whisker for type A. Now similarly, I'll repeat the same thing for type B, which has been given in the part this. So 0.46 is lower quartile, sorry, what is that? Lower quartile, upper quartile, and median. 0.46 is median, lower quartile, upper quartile. The smallest number in time is 0.21 for type B, and highest is 0.96. Okay. Okay, this is type B drawn. Okay, what next? Compare the loading times for these two type of smartphones. So we can see that it takes more time, type A. So you can write that type A, its box is towards the right mostly, right? Most of the box. So type A takes more time to load the application than type B. That means type A is slower. Okay, question number 5. Screws are sold in packets of 15 and faulty screws occur randomly. Alright. A large number of packets are tested for faulty screws and the mean number of faulty screws per packet, that's important, per packet is found to be 1.2. So inside a packet, probability of faulty screw equal to 1.2 out of 15. So it will be 0.008%. Alright, show that the variance of the number of faulty screws in a packet is 1.104. Okay, so variance is NPQ. So N is 15. P which just found out 0.08. That is the success for us. Finding a faulty screw is a success. Finding a good screw is failure. So 1 minus 0.08 is 0.92. And we'll just multiply that now. 15 multiplied by 0.08 multiplied by 0.92. 1.2 times 0.92, yeah, it will be 1.104 shown. Part 2. Find the probability that the packet contains at most 2 faulty screws. At most 2. So probability of X less than or equal to, that is at most 2. Right? So it will be probability of x equal to 0, no faulty screw. Probability x equal to 1, only one faulty screw, or probability of x equal to 2. So binomial distribution is applicable here because all four conditions are there. There is a success and a failure. All cases are independent. There are fixed number of screws, or you can call them events, and the probability remains constant. All right. So binomial probability will be 15C0 for this. Okay, 0.08 to the power 0, 0.92 to the power 15, or 15C1, 0.08 to the power 1, 0.92 to the power 14. The sum should be 15. 1 plus 14, it should be equal to 15. And then it will be 15C2, 0.08 to the power 2 and 0.92 to the power 13. All right, these are the three cases. Let's put them in our calculator and we get 0.887. That's the probability. Okay, number 3. Find the probability that there are exactly 7 packets in which there is at least one faulty screw. How many they are selecting? Not 15. 8 packets they are selecting, and out of 8 packets they want exactly 7 of them to have at least one faulty screw. So first we should find the inside the packet first. In every packet there should be at least one faulty screw, so we have to find this probability first. So let's do that. Okay, probability that x is at least 1, that is greater than or equal to 1 out of 15. We have not gone into number of packets yet. It is inside a packet because the first part has nothing to do with this. It has at most 2. Now we are having at least 1. So we can write it a shortcut way, which will be 1 minus probability of x is less than 1, which is 0. We can write equal to 0 also. X is equal to 0. That is the case ruled out, and we'll get at least 1. So 1 minus 15C0, 0.08 to the power 0, and 0.92 to the power 15, and that will be 0.714. That is the probability of getting at least one faulty screw. Now we have 8 packets chosen and we want exactly 7 to have this probability. Okay, so basically probability of, let's call it y this time, y equal to 7. This is what we want, and total n is 8. Now we are choosing 8 packets, so it will be 8C7, 0.714. This is what we want in 7 of them, and the remaining one will have 1 minus 0.714. Okay, let's use calculator. Our answer is 0.216. Okay, next question number 6. A farmer finds that the weights of sheep on his farm have a normal distribution with a mean of 66.4. Okay, 66.4 kg. All right, and standard deviation is 5.6. Okay, 250 sheep are chosen at random. Estimate the number of sheep which have a weight of between 70 kg and 72.5 kg. Okay, so since there are 250 sheep, we will find the probability first and then we'll multiply that by 250. So let's draw normal distribution for ourselves first. Okay, that's the mean, which is 66.4, and we want between 70, which is more than this, and 72.5, which is also more than this. So we want this area under curve. So this one is 70 and this one is 72.5 kg. All right. So basically for finding this area, we should find probability of x is less than 72.5 since it's continuous data. So we don't have to bother about 0.5. And if we subtract probability x is less than 70 from it, basically let me use a different color to show you. If this is the area which is less than 72.5, this whole area, right? And out of this whole area, if I remove this black colored area, so I will be left with this area, and that's our target is. So let's find z for x is less than 72.5 first. So it will be 72.5 minus mean, which is 66.4, divided by the standard deviation 5.6. Similarly, we'll find z score for x is less than 70, which will be 70 minus 66.4 over 5.6 equal to, so I got this as 1.089 and this one as 0.6429. So let's make it 3. 0.643. So let's find the probability related to them. So probability when z is equal to 1.089 and probability when z equal to 0.643. So 1.089 first. So let's do that one. Okay. 1.08 is this one, 8599 here. Okay, let me show you. 8 and 9. 0, 8, 9. 9 is 21. Okay. So 0.8599 plus 21 will give us 0.8620. 0.8620 is the probability less than 72.5. Okay, now for 70 we had 0.643. 0.64 is 7389 and 4. 0.643. 3 is this one. So 10 more. So it becomes 0.7399. 86207399. Okay. So here it is 0.8620, 0.7399, and we have to subtract to find that area in middle. So if we subtract it, we get 0.1221. 0.1221. That is the probability that it will be between 72.5 and 70. But the question was, how many sheep are expected? Yeah, estimate the number of sheep which have weight between 70 and 72.5. So probability is 0.1221. So 250 sheep are there. So we'll multiply the probability and we'll get number of sheep. So it is 30.5 sheep, and we can't have a sheep in points, so we'll write 31 sheep. Okay, next. The proportion of sheep weighing less than 59.2. So 59.2, let me mark here. It is less than mean somewhere here. 59.2. Okay, is equal to the proportion of weighing more than y kg. Find the expected value of y. Okay, let's redraw the same thing because it will become otherwise very complicated. So what they are saying is that this is the mean again, 66.4. and this is 59.2, right? 59.2. Okay, so they're saying the probability that the weight of sheep is less than 59.2, the probability is same as a weight y and more than it. So we know that normal distribution is a very uniform kind of graph where one part is a reflection of the other. If this probability is equal to this probability, that means this number is exactly same distance from mean as this number. So let's find this distance first, which will be 66.4 minus 59.2, which is 7.2 kg. So this y will be exactly 7.2 away from 66.4. So 66.4 plus 7.2 will give us y, which is 73.6. Y is equal to 73.6 kg. Okay, next one. Another farmer find that the weight of sheep on his farm have a normal distribution of mu kg mean and standard deviation 4.92. 25% of these sheep weigh more than 67.5. Okay, let's try to redraw this. Okay, here. So this is the normal distribution graph. Mean we don't know. The 25% more than 67.5. So for sure 67.5 is here, then only it is possible to have 25% more than it. Otherwise, we know that more than mean is 50%. So 67.5 is definitely more than mean. Okay, and the standard deviation is 4.92 kg. All right, and this area is 25%. So from this probability, we have to find a z-score. Okay, but the problem is the z-score is related to less than, not more than, isn't it? That means we have to change this 25 to this, which is 75%. So probability is 0.75, and for this 0.75 we have to find a z-score. So let's go back to our chart. 0.75, 737486, here it is 0.7486. Can you see here? So it is 0.6 and 7. So our Z score is 0.67 and we need 14 more to make it 75%. So it's almost here. 13 is here. So we can make it 4. Okay, 0.67, 4, and now we'll use this Z score to find the mean. So the formula for mean is Z score is equal to whatever is the data minus mean over standard deviation. So we have Z score now with us 0.674 equal to x is 67.5. Yeah, this is what is given to us, but we don't know the mean, and standard deviation 4.92. We will do cross multiply here. So 0.674 multiplied by 4.92 minus 67.5 equal to minus mu. So let's see. So it came almost minus 64.2 equal to minus mu and minus cancel out. So 64.2 kg is the mean weight of the sheep. Question 7. A committee of 6 people is to be chosen from 5 men and 8 women. In how many ways can this be done if there are more women than men in the committee? All right. So we want total 6. So if there are 3 and 3, they are equal. That means we want more women than men. So let's say women, men. So we want more women. That means 4 women and 2 men will do. 5 women and 1 man will do. Then 6, all of them are women and there is no man. So 3, 3 was equal, so we increased 3 of women, so it became 4, 5 and 6. And this is the possibility, so we will interpret them into the combinations now. So we want to select 4 women out of 8 and 2 men out of 5, or 5 women out of 8 and multiplied by only 1 man, and then 6 women out of 8 and no man. So just add these 3. If you want to write here 5C0, that's okay, because that is 1, so that will help. So that will be your answer. So I used my calculator and I got this 700, 280 and 28. Sum is 1008. Okay, let's move on to second part. If the committee consists of 3 men and 3 women, this case, okay, but 2 particular men refuse to be on the committee together. All right, what is unaffected is, let's say, we are choosing 3 women. That is unaffected. Only problem is with men, okay? So they refuse to be together in the committee. So there are 3 situations. Let's call them man 1 and man 2. So 3 women are selected, multiplied by, now they are fixed, only difference will be with the men. So first man, this man is in the committee. That means this man is not in the committee. That means we have to select now, 3 women are already selected. This man is already there, 4. So we have to select 2 out of how many people? There are 5 men. 1 man is already in the committee, second cannot be selected. So we are just left with 3, and out of those 3 we have to select 2 of them. Same will happen if this second man is in the committee, but this person cannot be in the committee. So again 3C2. And the third condition could be that both the men are not in the committee. That is also a case possible, right? They don't want to be together, but it's not like that they can't be outside the committee. So let's put them out of the committee. So just 3 people left, and we have to select all 3 of them. 3 men out of 3, because 3 women are already there in the committee. So 3 men are selected from the remaining 3, and this will be the answer. So let me evaluate this. 8C3 comes out with 56. 3C2 will be 3. 3C2 again will be 3, and 3C3 will be just 1. So it will be 3 plus 3, 6 plus 7 times 56, which will be 392 selections. Okay, third part. One particular committee consists of 5 women and 1 man, means this situation. Okay, in how many different ways can the committee members be arranged in a line if the man is not at either end? All right, so we are sure that there are 6 people, 5 of them women, 1 man, and if they stand in a line, the 6, the man is not here, man is here, he can stand in one of these 4 places. So 4 combinations are possible for him. Now remaining 5 spaces, woman can stand anyhow they want. Okay, so it will be 5 factorial. 5 factorial is 120 times 4, 480.